Alkanes are generally unreactive. That when you just get your alkane and you expose it to maybe to a halogen without anything, it cannot react. When you get your halogen, maybe chlorine, and you mix it in the same vessel with an alkane, and you put them in darkness, you put that setup in darkness, then it cannot react. Why? Because these alkanes are unreactive. Okay? So alkanes are generally unreactive. But when you transfer your vessel, maybe this is your reaction vessel, and you put there alkane, and then you add there a halogen, maybe chlorine, because it is the common one, and this is your alkane, maybe methane. Okay? If it is in darkness, you cannot see anything, you can't see any reaction. Okay? But once you put this setup and you put it under sunlight so that it can receive the UV radiations, okay, then this alkane is going to react with our halogen to produce a halogenal alkane. Is that okay? Yes. And this is an example of a substitution reaction in that the hydrogen atoms on the alkane, do I have an equation? Do I have an equation? No, I don't have, I might not have. So that the hydrogen atoms on the alkane, they are going to be substituted with your halogen. Okay? This is your halogen in presence of UV light. Okay? UV. So you're going to form CH3, CH3, and then X. Now, depending on the concentration of this halogen. In that if this halogen is in excess, then all the hydrogens are going to be substituted. And instead of forming CH3X, you just form C and then X4. But if the halogen is limited, then few hydrogen atoms are substituted. Okay? And so now what is the effect of the UV light on this reaction? Because we have agreed that when you expose or when you put methane and chlorine or methane and bromine or methane and iodine in one vessel, you seal it, and then you leave them in darkness, they can't react. But when you put them under UV light, then they are going to react. So now the question is, what's up with the UV light? Okay? So the UV light, it is the one which initiates the reaction by breaking down the chlorine molecule, by breaking down the bromine molecule, by breaking down the iodine molecule into radicals. Okay? And so that cleavage, we call it the homolytic fission. And what is a radical? For example, if this is my halogen, and the halogen is, let me represent it as X2 because it is diatomic, and this halogen is exposed to UV light. It is exposed to UV light. Sorry for that. It is exposed to UV light. Then it will undergo what we call the homolytic fission to give you two. This is X. Sorry for that. X, but it is a radical. And then another X. We are going to write a mechanism so that you see how it is done. Now, what does that mean? What do these radicals, what are they? Now, the chlorine, if you remember, in our organic chemistry, the chlorine is joined to another chlorine molecule, to another chlorine atom in chlorine molecule by covalent bonding, where one chlorine donates an electron and another chlorine brings another electron, and they combine the two, they share them equally to form the chlorine as a molecule. Now, when they are exposed to sunlight, to UV radiations, then this covalent bond between chloride bond, this bond, it is going to undergo homolytic fusion. Homo means same, where each chloride atom is going to go away with one electron, like this. That one takes one, and this one takes one. It is one electron. The concept is whenever you see a bond, then a bond is made up, whether it's a covalent bond, whether it's an ionic bond, whether it is a dative bond, a bond usually has two electrons. So when the two undergo homolytic fusion, then one chloride atom is going to take one bond, one electron, and another chloride atom is going to take one electron. So the result is you form the radicals. Okay? And now how do we write radicals? If you write this, it is wrong. If you write this, it is wrong. Even similarly, when you write this, it is also wrong. But it is X, it is you write the element so well, and then you put a dot, and the dot must be close to the element. So this is what we call a radical. And so because these radicals have unpaired electrons, okay, the electrons are unpaired, then they are highly reactive. And so being highly reactive, then they are the ones that are going to induce this methane, this alkane, which is too unreactive to undergo a chemical reaction. Is that okay? And so that is why the concentration of our halogen determines which product is going to be formed. In that, if the halogen is in excess, then all the hydrogens here, they are going to be substituted. But if the halogen is limited, that is if the alkane is in excess compared to the halogen present, then you form such a compound. Usually it is a mixture, but one of them is usually a major compound, and a major compound is this. Is that okay? Yes. So we shall talk about the mechanism. You have nothing to worry about. So a free radical is a chemical species with unpaired electron, and it is always very unstable and highly reactive. So that is your equation. CH4 plus 4 chloride. Now this chlorine, it is in excess, or it is in equimolar, depending on what you have, then you bring what you need. So this one is in excess, so that's why all the hydrogens are substituted. However, if chlorine is limited, then you form this. If chlorine is limited, then only one hydrogen is going to be substituted. Is that okay? Yes. Now let's talk about the mechanism. Now, this is one of the most confusing mechanisms. And students usually say that it is confusing. But me, I take it to be the easiest mechanism of all organic mechanisms. Why? Because it is fun. It is interesting. Okay? But anyway, it follows a free radical mechanism like how you saw. Okay? And it is usually a chain reaction. And what is a chain reaction? A chain reaction is that reaction where the products here, maybe let's say you have A reacting with B to form maybe C plus D. Now, if this reaction is a chain reaction, these are the reactants and these are the products. The products here become the reactants in the next stage. You form C plus D to form E and F. Okay? You form E and F. Now this one becomes a chain reaction. Then also the products here can become the reactants here. E plus F, and then you form your products. So if the reaction is in this format, then it is a chain reaction, where the products in this step are becoming the reactants in another step, and so on and so on. So the above mechanism is a chain reaction where the products become the reactants in the next step, as you are going to see. And this reaction, it proceeds in 3 steps. 1, 2, 3 steps. And the first step is the initiation stage. The initiation step. And actually, this is the most important stage. In that, if, like I told you, if you react, maybe if you put your methane in a reaction vessel and you add your chlorine in the same vessel and you leave the whole of this setup in darkness, then they cannot react. And why? Because this step won't occur. Okay? You won't initiate. And in the chain initiation step, what happens there is you form radicals. You form radicals. Let's write the mechanism for the other one step by step. It is CH4 plus chlorine. Let's use this one for instance in presence of UV light. Is that okay? UV light. That was right. You form CH3. Now this one is in. Let's first write when chlorine is limited. So this is Cl and then plus the hydrogen chloride. It is a substitution reaction. Can you please mute? So it is a substitution reaction. Now, for this reaction to occur, you must first initiate this reaction by forming radicals. The highly reactive species, the radicals. And what happens? The radicals are going to get exposed to sunlight. Okay? CH3, so the Cl with another Cl. Okay? So when they get exposed to sunlight, then they are going to undergo what we call homolytic fission. Okay? And one chloride atom takes one electron and another chloride atom takes another electron. As simple as that. Now in organic chemistry, if you see an arrow, then this arrow shows movement of 2 electrons, and the head of the arrow points to where the electrons are moving. And electrons always move from electron-rich species, or you can call them nucleophile, to electron-deficient species. But now, because here it is one electron that is moving, then we get this arrow and split it into 2. Okay? And half of it shows the movement of the other electron, and half of it shows the movement of the other one. Is that okay? So in other words, these 2 chloride atoms, they are going to share the electrons equally. And so here we use the 2 half arrows. Why half arrows? Because this one is a reversible reaction. Okay? So we represent, now after writing, after they have shared the electrons, then you form the chloride radical. So because there are 2 of them, so you put a 2 here. Or if you don't want to write a 2, then you can write Cl plus another Cl. So this is the most important stage, okay, as far as this mechanism is concerned. You first form radicals. And now, since these radicals are too reactive, is that okay? Then there are these radicals that are going to initiate the reaction. So after forming radicals, then the next step is propagation stage. Okay? Propagation. You propagate. So what's up with propagation? Let's see what happens under propagation. So you have now your methane. So I have no problem if I write it like this. CH3. I put a 3 here. And then, why am I writing like this? I just want to expose this bond. Okay? And then plus my radical. My chloride radical. The dot must be there. And don't write a ring. Don't ring. It is just a dot. Now the mistake which you make, you write a dot, but when you are making an arrow, the dot disappears. Now it's not good. Usually write it so that even when you write an arrow, it will be seen. So now because this radical is highly reactive, then it will come and it will induce this carbon hydrogen covalent bond to also undergo homolytic fusion, whereby it will come and donate this one electron to the hydrogen, and also the hydrogen is going to go away with one electron. Okay, and the two combine together. Then the remaining one electron is going to be taken by the carbon. Is that okay? Now we don't write straight. They can't be straight. If you write straight arrows, we shall cross you. And if let's not say straight, and for you exaggerate and you write, this is also wrong. If at least let it be curved, okay, but not over curved like this. This is madness. Okay, this is madness. So now after this, then still half arrows. Why half arrows? Because it is a reversible reaction. Okay, then you're going to form our methyl radical. Okay, let me write it like this. Our methyl radical, CH3. Okay, sorry for that, I just want to be speedy. With a dot on carbon, not hydrogen. The dot is on carbon. It is one dot. Sorry for this. Let me make it one dot. And then hydrogen chloride. Hydrogen chloride. Now, this radical that has been formed, okay, it is going to react with a neutral chloride, so the chlorine molecule, CH3, slowly by slowly, and then reacts with chlorine molecule, okay, Cl. Is that okay? And it is the same way. This one is going to bring its one electron, then this one also brings its one electron, and then this one takes the one electron. So that, oh, sorry for that. So that, what do you form? It is half arrow. You form CH3, and then Cl plus this one chloride radical plus the chloride radical. As simple as that. Then the next thing that happens is chain termination step. Okay, you're going to terminate your chain. And how do you terminate the chain? By reacting the radical with another radical. Otherwise, if this remember there were two here. Okay, so it is one that reacted with this. So the other one that is formed, it is going to react with this one that remained, so that you terminate the chain. You terminate the reaction. Otherwise, if you don't terminate the reaction, then you cannot get the marks. And how do you do this? You do that, okay? And it is half arrow because it is a reversible reaction. And finally, you form this. So it is as simple as that. Is that okay? And so when we are marking, we shall give you, let's mark, I hope you can see. We shall give you one mark for this, a mark for this, a mark for this, and one mark, a final mark for this. So depending on mark allocation, each step here is a mark. Is that okay? Yes. So literally, that is a mechanism. Initiation step, formation of radicals, then propagation step. Here the free radicals generated react with neutral molecules to form new radicals. You saw it. Okay? That is, the radicals formed react with neutral molecules to form new radicals. Now the new radicals also react with neutral molecules to form new radicals. Now if chlorine is in excess, you continue with this until when all the hydrogens are substituted. Is that okay? And we are going to continue with it. Then finally, with chain termination, then the free radicals react together to form neutral molecules and you terminate the reaction. Is that okay? Yes. So, note, the above reaction is not good in synthesis. Why? Because it yields a mixture of different compounds. Because I've told you that in excess, all the hydrogens, they are going to be substituted. Now for you, when you want to use it in synthesis, maybe they have told you, synthesize, synthesize, show how you can prepare this CH3, then CH2, maybe show how you can prepare CH2, and then Cl, and then from, okay, this is from, maybe from alkene, an alkene, CH2, and then CH2. And then for you, what you do, you first add hydrogen in presence of nickel, hydrogen in presence of nickel, at 150 degrees Celsius. 150 degrees Celsius. And then you form your methane. Now once you do this, it is not good because it is going to be unreactive. And then for you, after doing this, you add your chlorine, okay, in presence of UV. Yes, it is good, but not advisable to use such when you are writing a mechanism. Why? Because first of all, it is hard to limit this. Yes, it must be limited, but it is hard to limit this so that what you form is exactly this. Number two, when you form this, there is no guarantee that you will form chloroethane. You form a mixture of chloroethane, dichloroethane, trichloroethane, or tetrachloromethane. So it is not always good. Even when I give you to synthesize anything, this one should be the last option. That is if you have thought, and nothing is coming your neurons. Okay? Then this should be the last result. Is that okay? Yes. So let's see. Let's write a mechanism where chlorine is in excess. That one is the one which usually challenge students. Okay? Let's write a mechanism where chlorine is in excess. You have CH3, so the CH4 plus excess. I'm going to write just X. I'm sorry for this, but it's just to limit the words. Excess chlorine, and then UV. Now, when you are writing chemistry, please, you should be careful. Your symbols, your arrows, because that's what we focus on, symbols and arrows. That's what we focus on. So you should be as careful as possible. So if this chlorine is in excess, then you form tetrachloromethane. Tetrachloromethane plus 4 hydrogen chloride molecules, 4 of them. Now the mechanism We said it is a chain reaction. Let's divide our board. So the first step is the chain initiation step, where our chlorine undergoes homolytic fission, where this chlorine takes away one electron, and this one also takes away the other electron, and then you form what? The radicals. Actually, you should be doing this mechanism with me. You should be writing. So you form your two chloride radicals. So as simple as that. Then the next step is the chain propagation stage, where the methane, let me write it like this. This is a 3. Then to spread this bond so that our mechanism becomes good. So it is going to react with one chloride radical. So this is a radical, where it will bring away this one. Now the arrows must not be hanging. Let me at least do this. Oh, sorry for that. Then this bond comes, and then this one also goes on the carbon atom. Okay, then you form, it is half arrow pointing in both sides. Then you form the methyl radical. Okay, the C methyl radical with a dot. You can put it here or you can put it here, but it shouldn't be far. Then plus, that's pretty good, HCl. Now this methyl radical, now it is the one that reacts with a neutral molecule of chlorine, CH3. Somebody wants to be admitted though. So CH3 radical reacts with a neutral molecule of chlorine. Okay? So this one brings away the one electron here, and this bond, the chlorine also takes one, and then the remaining goes on the chlorine. Okay? And so you form. Why are we using half arrows? You should be knowing. You form the CH3, CH3Cl plus the chloride radical. Now, this is why it is called a chain reaction. There is a radical here. Now, it is a chain reaction because now these are the products in this stage. Now, the whole of these products now, they are going to act as reactants. Okay? In the next stage, sorry for that. So you write these ones the way they are. Let me write the Cl here, and then the carbon, and then I spread one hydrogen bond. Okay? And then the hydrogens. That's hydrogen, and then that is another. So I've just written this, okay, but I've spread, I think that one is the correct English, the bonds. Okay, so this will be our radical. Then this one will bring the one electron, this one take away the one electron, and then this one goes on this. So it is the same thing. We are just repeating this. However, because it confuses students, I have to repeat it. So you form a chloromethane radical. CH2. This is CH2 with a radical. Okay? Sorry. This is a radical. Sorry for that. And then plus the Cl radical. Then this one, the radical, this is Cl. The radical, the Cl, you should be following because the letters are becoming poorly written. This radical, it is this one, reacts with a neutral molecule. You should be writing with a neutral molecule of chlorine. Yes. Same thing. If you are writing, you should be finishing. And then this one goes here. and then this one becomes Cl2, okay, and then CH2. Is that okay? And then plus the chloride radical. So it is as simple as this. Then this one, the whole of this now goes here. That's why it is a chain reaction. Cl2 is becoming, but you shouldn't get tired. Even me, I shouldn't get tired. So let me spread this bond. And then this one, let me just put it here. And then the chloride radical. So this one brings this, and also this one brings this, and then this bond goes to this. Oh, sorry for that. And so what do you form? You form the dichloromethane radical, Cl2, CH radical, okay, plus hydrogen chloride, HCl. As simple as that. Then now this radical reacts with another neutral molecule. Let me put it here. Okay, here. Reacts with a neutral molecule, Cl2, CH, CH radical reacts with a neutral molecule of chlorine. Okay, so that now this one brings one, and this one brings one, and then this one takes the one. Okay, and so what do you form? You form Cl3, and then CH plus hydrogen chloride. Oh, we are almost there. Then this one, no, it's not hydrogen chloride. It is a radical. This one is not there. So it is a radical. Then this one, chain reaction, the whole of this comes here, CH, CH. Oh, let me spread the bond. So it is Cl3, C, and then this is H. Okay, slowly by slowly, so that we get this is Cl. Then this one brings the one. Okay, this one also, the bond takes one, and then this one also, the remaining one goes there. And so what do you form? Remember, it is half. We use half arrows because it is a reversible reaction. What do you form? Yes, you form Cl3, then C radical. Okay, then plus hydrogen chloride. As simple as that. Then finally, now this one, a radical, reacts with a neutral molecule of chlorine, Cl3, Cl3, there is a dot here, then reacts with a neutral molecule of chlorine. Okay, let me rub this so that you don't say that now, teacher, what is that? You are confusing me. Let me rub this and this one. So when this one goes there, and then this one like this, and then you form a chloride radical. So the whole of this, by the way, is chain propagation stage. Chain propagation. So you form C, and then Cl4, tetrachloromethane, plus a chloride radical. Now we are there. Now the next stage, or the final stage, is the chain termination stage. And in chain termination stage, here the radicals react with each other to form neutral molecules. And so from this reaction, you have this radical, okay? And you also have one that remained here. There are two, but you are using one, so one remained. So it can react with, the chloride radical can react with chloride radicals, okay? Chloride radicals to form chlorine, which is a neutral molecule, Cl2, okay? Cl2. Now this is one step. The second step is, because these reactions are occurring in the same reaction vessel, there is no guarantee that the whole of these radicals, let me get some different pen. There is no guarantee that the whole of these radicals, these ones, there is this one, there is this one, there is also this one. So there is no guarantee that all these radicals, they will react with chlorine and they get done. Some can remain. So those which remain can react with each other. For example, CH3 can react with CH3. CH3 radical can react with CH3 radical. And what do you form? What do you form? You form CH3. CH3. You form ethane, in other words. These ones, they might also remain there. So in other words, with the chain termination step, the radicals react with each other, okay, to form neutral molecules. Is that okay? The radicals react with each other to form neutral molecules. And so here you form Cl3, C, another C, another Cl3. And so when this happens, then the reaction will be complete. Is that okay? The reaction will be complete. Now let me go to the chat box to check for your questions. In case you get lost, you got lost somewhere. This is the time to check for your questions.